Okay, so now you have done C and D on your own. So let's just go over it. C, we don't have any forces that are acting horizontally. So that's why we have 0 and 0. So there's no net force. And it's not going to move in either the left or right direction. Vertically, you only see up 25 and down is negative 25. So when we add those together, you're also going to have 0 and we're not going to move in either direction. For D, in the horizontal, we do not have a left force acting, but we do have a right force. Well, since the right force is the only force that's acting horizontally, then our net force would be 20 newtons to the right. Vertically, up 25 again, down negative 25. When we add them together, we get 0. So overall, for diagram D, that object is going to move to the right, just like diagram B. Okay, here are some examples of balanced forces. If you have someone that's just sitting in a chair and you're not moving, that's a balanced force. The person is not moving. You have an object that's moving at a constant velocity. Constant velocity means that number is staying the same. So there's no acceleration. There's no change in the speed. Okay. An object that's at rest, well, that means the object is not moving. Therefore, we have balanced forces. If your triangle V means, that means if your change in speed is 0, then you have a constant speed. Therefore, you have balanced forces. And also, if your acceleration is 0, same thing as I said earlier, that means your object has a constant velocity or is not moving. But if the acceleration is 0, then the forces are balanced. Okay. Unbalanced is just the complete opposite. Okay. First one, 20 newtons to the left, 30 to the right. Well, both of those are in the horizontal, and the 30 newtons to the right is bigger. So therefore, the object is going to accelerate to the right. We have an accelerating plane. That means the airplane is increasing the speed. If A is not 0, that means A is some number. Even if acceleration is 1, that means the change in your speed over a certain amount of time is 1. So you are accelerating, therefore there are no balanced forces. Last one, if the change in velocity is not 0, that means we have some number that says our velocity has changed. We're going from 15 to 20. That is a change of 5. So therefore, the forces are not balanced and it will move. Okay, and the net force is the sum of the forces we are adding. Okay, you're going to come across pictures of free body diagrams that have multiple arrows going in the same direction. Well, horizontally, you see at the top one, we have 2 arrows going to the left, 4 and 3. Where since they're on the same side, we can add them together to get the overall left force. -3 plus -4 equals -7. Then on the right, we have 5 and 8. Add them together, we get 13. That is the overall right force. And to get the net force, the sum of the forces horizontally, we'll take 13 plus the -7 equals 6 newtons. And then since the right has the bigger amount of force, that's the direction that we're going to go. Vertically, up, we have 4 and 2. When we add them together, we have 6. Well, that matches the number of gravity's force number, which is -6. Well, the numbers are now the same.